Okay, let's get started right away with arithmetic sequences of the linear type, as we're going to be doing here. By the end of this, you will have an equation to put into that block. Let's start with an example. Let's take the example of the sequence 3, 7, 11, 15, 19, and 23. Now remember, these are the terms of the sequence: term 1, term 2, term 3, term 4, etc. Now, I've told you this is an arithmetic sequence. I've told you it is linear, right? But you can quite easily see that there's a constant difference here. We're going to calculate that anyway. T2 minus T3, T2 minus T1, this is the difference. That's 7 minus 3 is equal to 4. Now remember, if this is to be an arithmetic linear sequence, the term T4 minus T3 must equal the same as this term over here. And this is true for any term minus the term before. So any term like this would work. Let us continue now and just see the difference. Right, so 11 minus 7 is 4. 15 minus 11 is 4. So this is an arithmetic sequence and is linear. Another thing not to forget, this n variable is going to be popping up in the next couple of videos. n1 is 3, n2 is 4. This is the nth number of the term across the series, across the sequence. What is T3, for example? 11. What is n5, for example? 19. Okay, let's start with another example. You're given a formula. an is equal to 4 minus 3 n minus 1. Right? Let's figure out a bit more about what this formula could be. I've told you it's arithmetic sequence, it's linear. But let's solve for the first three terms. Right, we set up our table n1, 2, 3, which is the equivalent of term 1, 2, and 3. We solve the first term. We go a1, we substitute this for our n, equals 4 minus 3, 1 minus 1. We know that's going to equal 0, which is going to take us straight across to 4 minus 0, which is going to equal 4. We're going to sub this 4 in here. Now let's go back to solve team 2. Again, we've said a2 over here, and we've said n is 2 over here. Let's solve straight ahead what that means. 4 minus 3 is 1. We sub that 1 in. And we lastly solve term 3. We find it to be negative 2, and we solve that here. Now the difference, let's just check that those differences are constant. We said term 2 minus term 3, that's 1 minus 4, and we found that that is equal to negative 3. And those are our terms, as T3 minus T2 is negative 2 minus 1, which also equals negative 3. Right, why might this be useful? The beauty about an arithmetic sequence is you can solve for any number in the sequence. So what if I wanted to find the 21st term? 21st term would be 4 minus 3, and now there's 21 minus 1. And this is useful, and we can go ahead and we can solve that is equal to negative 56. Right, this is how to calculate the general formula of an arithmetic sequence. We know that T1 is equal to A, or we're going to set T1 is equal to A. This is the first term in the series. Then we're going to say ahead, term 2 would equal the first term plus the constant difference. What do we know the first term is? We know that the first term is equal to A. So we're going to go ahead and say that is equal to A plus D. Term 3 would be term 2 plus D, another constant difference. We know what term 2 is. Term 2 is A plus D. So we're going to say term 3 is equal to A plus D, and this is equal to A plus 2D. Now you're going to start to find a bit of a general formula going on here. A plus D, A plus 2D, A plus 3D. And we notice that this 3 is co-aligning with 1 less than the term number. So we're going to continue doing that up to n times. And we find that if we wanted to solve the nth, and the nth can mean anything, so the last value of the series, we know that it is the equivalent of the value before it. So this 4 is now a 3, and this is the value n minus 1, plus a constant difference. We can then solve that value n to equal a plus n minus 2, if this is n, 4 minus 2 is 2, 3 minus 2 is 1, and there's a 1 here, And this is now n minus 2 times d plus our last d. And then we can finally solve that as to a is n minus 1 times d. And then, just like that, we get our general formula. A plus n minus 1 times d. Make sure you understand this part of it, very important. If you ever forget it, you can then derive it yourself. But now we can go straight ahead and we can lock this into our equation for an arithmetic linear sequence. And we're going to put that right there. And we're going to go on to the next videos to continue filling up this table.